Hello to you all. I'm going to be doing something a little bit different, kind of starting in this segment. I've been spending a lot of time streaming and then editing the VODs of my stream, which just kind of boils down to me spending a lot of time listening to myself talk about doing game dev instead of actually doing game dev. So instead of streaming as much, I think I'm just going to be doing kind of devlogs, maybe weekly devlogs or so. Right now, you'll see the movement is a lot smoother than it used to be. I'm interpolating moving between tiles. It's not like a stepwise jump tile to tile. The camera kind of tracks the player and blends across tiles as the player moves. So previously we added this entity state moving, but I wasn't really doing much with it. And so I have expanded around this state to allow us to smoothly transition from one tile to another. I introduced this moved from component. This is in the entity view here, but moved from is essentially another component that is just a math vector to f. So here in the move procedure, if we do perform movement as the player, then if we are actually able to move to some destination, we will add the component to our entity, and then we will set the component itself to the current position of the entity, and then we will update the position of the entity to be wherever the proposed movement position was, assuming that we can move to that position. And so this way, we basically keep track of a from and a to while we're moving. Then we do a state change and we go into moving. So there's another procedure here, which is get entity moving position. This is basically going to take an entity view, and it's going to do a linear interpolation between the from position and the to position. The reason that we do this is because we want to represent the entity's current position on a tile by tile basis. We don't ever really want the entity in the game state to be considered like halfway between a tile, because these halfway between tile states are just for the sake of animation. And so we hoist out the computation of the transition position, the transitionary position, so that this way the camera can also correctly update its position. Otherwise, the camera would jump in discrete tile units while the player is kind of sliding between tiles. And this actually causes a lot of like, let's say, jagged movement in the camera. It's very awkward. In move here, we were previously updating the camera position down here. If the player was able to move, then we would set the camera position somewhere here. But now we hoisted that out to something that's probably a bit more logical here, which is after we do all the entity updates, then we will update the camera position in the top level game loop before we enter the render pass. So another thing we have is entity swarming. So previously, before entity swarming, if I move this, for example, this way, and I stall and allow enemies to approach, these enemies will all be trying to approach me, but they'll line up right in front of me. And the reason is because the path of least cost has them move directly toward me linearly, but they're blocked by entities. And when we are doing pathfinding on the map layer, we don't take into account entity position. But now I've introduced enemy swarming, and so now the enemies will surround me if that is what their movement AI is designed to do. So with entity swarming, let's see if I can kind of recreate the same situation here. I'll stall with the attack key, and you'll see as these other enemies on the left approach me, they'll move around the blocking entities and get into a position where they can actually attack me. So they'll move there. This guy to the left will move up, so that's the path of least cost, and then they'll all take their turns attacking me. And here's how I kind of accomplished and compartmentalized that. So I introduced another component, which is AI, and this component currently just has a nested enum definition for movement strategy, and then I have a movement member here, which just tracks whether or not an entity will perform random movement or will attempt kind of more of a swarm tactic. And I split out the movement logic from move to this these movement strategy procedures. So this is movement random, and then below this is movement swarm. And movement swarm will, I won't go into it in too much detail, but essentially it will attempt pathfinding. Pathfinding succeeded, and we are not able to move to the position that pathfinding recommends. That indicates that we're actually being blocked by an entity. It's something that's not on the map. So then we will look for nearest available neighbors. In other words, it will be the next tile of least cost, at least computed Manhattan with Manhattan distance in this case. And then we'll just try pathfinding again. And then finally, if that fails, then we will just attempt random movement. I don't know if attempting random movement's the right thing to do right now. We could tune that later. Move procedure for the enemy kind of just looks like this now. So we assume that this particular enemy always has AI, and AI will have a movement strategy. And so if we are the random case, then we just perform random movement. Otherwise, we perform swarm movement right now. And I think basically everybody is set to swarm movement. One of the things I need to do is kind of add like an aggro distance. And so maybe enemies will move randomly. Certain enemies will move randomly until you enter their aggro distance, in which case they'll start pursuing or swarming or whatnot. That's it for the recent interesting updates. Thanks for tuning in. I hope to see you next time, and I look forward to making the next segment. Peace.